Hey guys, welcome to my YouTube channel. My name is Joe Mojama and I'm going to show you how to make a sun tracking system. And at the end of this video, I will request you to like it if you like it and subscribe to my channel. Quickly, let me take you to the title of the project. If you want to make a solar tracking system and you call it a pathfinder, the aim of the object is to come up with a solar tracking system that will track the solar UV light for a solar panel, aiming in increasing efficiency of the power obtained from the sun by the range of 50 to 40%. Quickly, specifications that we are going to use. We are going to use Arduino Uno, which is using 5 voltage as you can see, and it has an embedded microprocessor at Mega 328. We are going to use 2 LDRs and we are going to use 1K ohm. I have the ohms with me. We are going to use 1K ohms. And now we are going to use a servo motor. This is a servo motor. It has 3 cables, 2 for transmitting power, that is the positive and negative, and 1 for transmitting signal. And of course, we need a photovoltaic panel. That's a solar panel, which is of around 1 watt. We need a software. We need a software that we will be using to code. That is, you see, our microprocessor needs to be coded so that it will do the transaction. Before I take you to the code, let me take you to the flowchart of information. We began by initializing our system, that is the start. And then the system will initialize. The LDRs will read the values. The values will be in an analog form. So we need to convert them to digital by using our sensors. And then the microprocessor will receive the information and then it will compare the data between sensor 1 and sensor 2 and then send the relevant signal to the drive signal for the servo. And then the servo will actuate our panel and then finally stop. If there is an emergency, there is a stop key, it will restart the system again. Back to our code, we are using a C++ software whereby we recall hash include my servo and integer position 90 is our initial position of the solar panel when the sun is directly perpendicular to the panel. And then we include sensor 1 at 0. It means we'll be using pin number 0 if you can see. And then sensor 2 A1, and then tolerance, we are going to give it a tolerance of 2. And then the code is too long, you will code and then you will give something. Hardware schematic. This is the hardware schematic. We have Arduino Uno, we have RDR1 and 2, and the servo. Yeah, the circuit was connected, as I'm going to show you quickly. This is the proof that indeed with the tracking system we are able to increase efficiency by 23%. We did this, collected this data on an LDR that is fixed and then an LDR that is tracking for tracking movement. On a sunny day, bright sunny day, from 0700 hours to 1900 hours, that is at the evening, we choose particularly 1100 hours for LDR1 and LDR2 when the system is fixed. This was the result. For LDR1 and LDR2 for a tracking fault, this was the result. You can see for LDR2 we are able to increase the output by double, 2.8 to 4.0, that's around 0. Efficiency is calculated by output fault over the input fault. The input fault was 5 from our Arduino, which we were using, and our sensors are using 5 volts. So we calculated the input, the output, which is 4.0 over the input, which is 5, and the efficiency for a tracking system was 80.54. And the LDR for LDR2, which is a system that was not tracking, the efficiency was 50.14. The difference between the two is around 23.4, and our target was to achieve 30% efficiency. Thank you, and now I'm going to show you a system how it's going to work. Yes, as we said, this is the embedded cover. It's a cover to mount. These are the two LDRs that we are talking about. They are the ones that are going to measure the intensity of light, and this is of course a stand, and these are power source, these are switch. But for now we are going to power 5 volts using a USB cable. And yes, our system, you can see it's detecting light of the pulp. No wonder it's tracking. So I want to show you using, when we come close with a torch, you see, if the sun has changed to this direction, let's say, and then let's say in the morning the sun is at the far east, down, where the fixed sensor cannot reach. And then as the days goes by, assume it's 9 p.m., the panel is still tracking. At the evening and follows. You see, our system is able to detect tolerance of 2. It's so sensitive, even if the sun moves, so long as the difference is 2. Thank you, and may you see you next time. That is it.